Hello everybody and welcome to your video notes. This is Mr. Basil and let's get to it. So this video is your introduction to Learning Target 4.3. Learning Target 4.3 is about Lewis structures, Bohr's atomic model, and ion formation. Those are kind of like the three main things that will be in this learning target. In this video, I'm going to be going over what is the Bohr's model, what is Lewis dot structure, and also what you need to know about valence electrons. So let's get to it. So Bohr's atomic model. So Bohr's model is just a way to represent an atom in a 2D way. So a Bohr model. Okay, so it's a 2D representation of an atom. An atom's really three-dimensional, so it's not exactly 100% accurate, but it does a great job of showing how things could look and help you understand the important things about an atom. Alright, so here, so just scroll down a little bit. Here is a very general and simple Bohr's model. This is the Bohr's model for hydrogen. And I would recommend maybe just for each of these pictures just copying it down, because we're gonna show you the Bohr model of specific elements or atoms, and then we're going to come back in and then we're going to be doing the Lewis dot structures for them as well. So go ahead and pause and write this down if you need to. But this is for hydrogen, and you'll notice that going outside of hydrogen, we've got this middle part right here which represents the nucleus of an atom. So the nucleus is where the protons and neutrons are at. Notice how there's only one electron here. And then we've got these different electron energy levels. You can think about these as orbitals. The electrons aren't actually orbiting the nucleus like a planet, but you can think about it like that. But again, it's just a model because really it's a three-dimensional thing. But for now, you can just think about it like there are these energy levels that the electrons can kind of like live in. And you know, you got your nucleus in the middle with your protons and neutrons, and then you got the electrons in this area outside of the nucleus. Now hydrogen just has one proton. If you look at the periodic table, it's element number 1. That's how we know that. And so there's one proton in the middle here. One proton. It's 0 neutrons, so I'm not even going to write that in there. And then you just have the one electron. Since there's one proton and one electron, we know this is neutral, meaning that there's no charge for the whole atom itself. This is the simplest. This is as simple as it gets. I'm going to show you some other ones that are a little bit more interesting. So this is for sodium. And you know, if you look at sodium on the periodic table, it's element number 11. And so there'd be 11 protons in this one, and we don't know how many neutrons there would be, so I'm just going to put a question mark next to the neutrons because there's no mass number given to me. I can't look at the periodic table and use the mass that it's given because that's the average mass of all sodium atoms. For this specific sodium atom, we wouldn't know, so I just put a question mark there. But you can see that it's very similar to the hydrogen atom in that we've got our nucleus in the middle, and then we've got the energy levels that have the different electrons that are on it. Now if you notice, there's 11 protons and there are also 11 electrons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 protons, 11 electrons means that this is a neutral atom. All atoms are going to be neutral unless I specifically tell you or you see that there's a charge or it says something about an ion. So when we're doing these, you want the number of electrons out here to match the number of protons that are in the nucleus. You might also start seeing a pattern. You don't need to worry about how to make this yet. That's going to be in the next video. But yeah, see if you can start noticing any patterns here. Then we've got carbon, so 6 protons, and this just happens to say it's 6 neutrons, so that's nice. And 6 protons, there are 6 electrons on the outside here. Oxygen is element number 8 on the periodic table, so it's 8 protons. And it just so happens that there's also 8 neutrons, and that's just because that's what this picture says. I got 8 electrons going around the outside as well. And then potassium, potassium's exciting. Look at how much is going on here. So potassium is element number 19. So there's 19 protons. Notice that there's not the same amount of neutrons, and that's okay. That's normal. It just happens. The number of neutrons is not affected by the number of protons. That's just given to me because that's what this picture says. And if you count these on the outside, you'll see that the amount of electrons equals the amount of protons. Okay, so now before we get going on to the Lewis structures, there's one thing I want to define for you, and that is a valence electron. So valence electrons they are the electrons that are in the highest energy level. They're electrons in the highest energy level for a specific atom. So in this case, in the most simple case, so for hydrogen, there's only 1 proton and 1 electron. So the highest energy level would be the one that has actual electrons in it. So these 2 energy levels exist, and they are higher than the first energy level, but there's no electrons there. So like this is energy level 1, 2, 3, and you can imagine 4 and so on going out here. But there's, in the first energy level, which is the highest energy level for this one, there's only 1 electron. So there's 1 valence electron. I can spell. Okay. In sodium, if you look here, their highest energy level is here. This one also has 1 valence electron. Valence electron. Because these ones in the middle are not valence electrons. They're there, but the ones that we care about a lot in chemistry are just the valence electrons. For carbon, 4 valence electrons. And then for oxygen, it would be 6 valence electrons. And then last but certainly not least, there's all this action going on for potassium, but this one also only has 1 valence electron. Okay? So for a Lewis structure, we're only going to draw the valence electrons. Okay? So for a Lewis dot, structure, only draw the valence electrons. Okay. And so for hydrogen, this whole thing right here, let's switch colors just to make it fancy. You're just going to write the element symbol, which is H, and then just a dot to represent the 1 valence electron for hydrogen. Okay. And then over here for sodium, same thing. We're only drawing the valence electron. So for this one, it would just be sodium is Na. It has 1 valence electron as well. So I'm just going to draw that. And then coming over here, carbon. I'm just going to write C for carbon. That's its element symbol. You can look at the periodic table to determine that. And then this one is 4. So I'm just going to draw 1, 2, 3, 4. And you want to start by having 1 electron on each, quote, side. You can think of it like there's a box. And if you can do 4 on each, 1 on each side, do that. But then after you get to 4, then you have to start adding on more. So like 4, and you don't want to draw that box. That was just to help you visualize that. And for oxygen has more than 4. So O. So I'm going to do my 1, 2, 3, 4. Then I need to get to 6. Then I'm going to start pairing them up like that. Okay, so that'd be oxygens. And then potassium, it's pretty simple. Element number K, or element K, and then just the 1 dot like that. Okay, we'll go over more examples of this and more in the next video. So thanks for listening, and see you next time.